Yes, एक्चुअली हम जो वे करते हैं दैट इज मास वी आर वेइंग, वी आर बैलेंसिंग दैट ना। वी डोंट डायरेक्टली डू द फोर्स कैलकुलेशन, हम फोर्स कैलकुलेशन तो नहीं करते ना, हम दोनों तरफ वेट रखते
Yes,
हैं,
sir.
वेट के हिसाब से बैलेंस करते हैं। तो व्हाट वी मेजर वी कैंसलिंग द, दोनों डायरेक्शन में आपका जी लग रहा है उसको हम कैंसिल कर रहे हैं। तो हम तो सिर्फ मास मेजर कर रहे हैं ना, आई गेस, आई थिंक। ओके, इवन इफ लेट अस अज्यूम कि भी हमारा 6 kg ही मास है, एंड वी आर मोस्टली मेड अप ऑफ कार्बन और ऑक्सीजन। तो लेट अस अज्यूम कि हमारे पास कितने एटम होंगे कार्बन या ऑक्सीजन के, यू कैन कैलकुलेट दैट। 6 kg में कितने होंगे इजिली से, कार्बन का 12 होता है, ऑक्सीजन का 16 होता है, तो एवरेज ले लो, 14 ले लो। तो क्योंकि नाइट्रोजन भी हमारे अंदर होता है, तो नाइट्रोजन का एक बेस मान लो कि 14 है हमारे पास मास नंबर। तो हाउ मेनी एटम्स वुड बी देयर? 6 kg, is it correct? uh, is it correct? कई लोग तो 6 6 किलोग्राम के गोल्ड के नेकलेस या कुछ वैसे भी पहन लेते हैं। तो हाउ दैट इज पॉसिबल? एक लड़कियों में से पूछ सकते हैं कि अगर नेकलेस वगैरह बनाते हैं तो करीबन वो 1 kg तो बन सकता है, दैट इज नॉट अ डिफिकल्ट थिंग, बट 3 4 kg के तो नेकलेस या कुछ और पूरे वो पहन लेते हैं। तो हाउ कैन बी दिस 6 kg? आई डाउट 6 kg। ये डिवाइडिंग बाय 10 एक्चुअली है ना, यानी आप 60 हो और आप उसे 10 से डिवाइड कर रहे हो। एक्चुअली 600 इज योर वेट, 600 is your weight and 60 is your mass. ये सभी 6 kg पे फोकस करेंगे, हम सब 6 kg के हैं, दे आर वेरी अंडरवेट। सभी के सभी
No,
अंडरवेट हो।
sir.
हाँ?
No, sir.
क्या बात। तो 60, आपका 60 किलोग्राम इज द वेट, and when you multiply with the g, that is 60 600, you can say roughly, अगर 10 से मल्टीप्लाई कर दे तो 9.8 ना लेकर के, तो 600 is your weight, you can say। तो योर मास एंड वेट में डिफरेंस है, ऑब्वियसली डिफरेंस है, बट हम जब बैलेंस करते हैं, अपने आप को मेजर करते हैं, तो वहां पे वो बैलेंसिंग करता है, वो जी के फैक्टर को नेगेट कर रहा है। तो मुझे नहीं लगता कि 6 kg के हम है, बट वॉट एवर, अगर आप 6 किलो के भी हो फिर तो आपको मे बी माल न्यूट्रिशन का प्रॉब्लम हो सकता है। 6 kg, मतलब मुझे लग रहा है दिस शुड करेक्ट। माल न्यूट्रिशन के शिकार हैं, हाँ। तो आप लोग एक्चुअली उस, जब आप लोग स्कूल में तो मे बी मिड डे मील नहीं मिलता होगा, अब तो बच्चों को मिड डे मील मिलता है। हो सकता है मिड डे मील नहीं मिलने के कारण आपकी हेल्थ थोड़ी वैसी रहेगी। Okay, the main important point is that whatever the mass you have, whatever the mass of atom we measure, that is hardly that, what we measure actually, that is just 1% of the actual mass, or you can say less than 1%, roughly. It means I'm saying that if I'm a 60 kg person, then my actual mass is 6, means you can say in percentage, that is percentage you multiply with 100. So that is 6,000 kg. That is the actual mass I have. But when I measure myself, I just get a percent of that particular value. So where the 99% of mass has gone? So 99% of mass has gone to arrange these quark within the nucleus, because you need, because they are charged particle and they have a very high value of charge, means not very high but at least a value of charge, and that is in a very small dimension. So it is impossible to keep these charges in a very close manner, means fraction of Fermi. If you are talking about the proton, so proton is less than a Fermi. If it is less than a Fermi, within that Fermi you are putting 3 charges, and 3 charges you can calculate the Coulomb in repulsion, how strong it would be. To balance those things and to have that kind of bounded system, 99% of mass has been converted into binding energy. So that is why you're not able to measure. तो जो हिग्स बोसॉन का एक अपने बीच में सुना होगा कि हिग्स बोसॉन फिर नोबेल प्राइज के लिए भी उसका प्रपोजल है कि भी उसको मिल गया है, बट अभी तक कंफर्म नहीं हुआ है कि हिग्स बोसॉन है या नहीं. द प्रेडिक्शन इज देयर कि जो लास्ट 2012 में जो हाइड्रोन कोलाइडर अपना रन किया था उसमें मे बी मेजरमेंट has given certain evidence that Higgs boson is existing. But the Higgs boson is also which is giving you mass that is hardly a percent. Rest of the 99% has gone, and those 99% is actually to make this bounded system of a nucleus. तो एक्चुअल अगर मेरा वेट पूछा जाए तो मैं तो 6000 kg का हूँ. अगर एक्चुअल वेट मेरा पूछा जाए, what you measure, it is just 1%. So this 99% has gone somewhere, and who has took this 99%? We will see that what are the particles that are taking these particular masses, and we will see something more interesting about the proton also, and about the neutron also. That neutron is actually a neutron, or it is also having a sub structure, or how the structure is there. Means neutron का structure क्या है और proton का structure क्या है. So we will discuss that also. So first we will go to the quark model. So last time एक formula मैंने लिखा था, Gell-Mann-Nishijima formula. So that formula is actually relating all the defined, you can say, the conservation principles which is concerned with the new quantum numbers, that is baryon number, lepton number, strangeness, charmness, isospin, third component of isospin, bottomness, truthness, all these new fancy quantum numbers that has been introduced to understand the decay process or any reaction which is being, why this reaction is happening and why this reaction is not happening. So we have to see all those conservation laws. And if the reaction is going through a strong interaction, then these conservation law has to be followed. If the reaction is going through weak, then these conservation law is followed, and this will change by 1 unit, something like that. We have a rules, set of rules which is relating all these conservation, means all these quantum numbers which we have defined. And Gell-Mann-Nishijima, they have proposed that there is an interlink between these quantum number also. They are not just introduction. For example, baryon number हमने define किया, that baryon is +1, if it is anti-baryon, it is -1, if it is non-baryon, it is 0. So there is no relation directly with the lepton number or strangeness or isospin. But when you introduce in that way, still they have interrelation. And what they have done, they have just took the particles and they plotted those particles on a graph, and that graph is having two axes. थर्ड एक्सेस का भी ग्राफ होता है, बट वो आपके सिलेबस में नहीं है तो हम डिस्कस नहीं करेंगे. बट टू एक्सेस यानी टू डायमेंशन ग्राफ हम डिस्कस करेंगे, which is concerned with the mesons and baryons. So when they have took two different quantum numbers, they have took strangeness and isospin, and that is obviously the third component of isospin. So T3 and S, they have focused on that number and they have drawn a graph, and in that graph these two are two axes. So they took the horizontal axis as a strange T3, that is third component of isospin, and the vertical axis is the strangeness. And they started putting the these mesons and baryons according to their spin, because spin is also, mesons are spin 1 and some mesons are spin 0, and some baryons are spin half and some baryons are spin 3/2. So they have drawn four different graph concerning with different spins. And when they have plotted that, then after plotting that, they can directly see the symmetry of the quark arrangement within these particles. अगर वो ग्राफ याद हो जाएगा, तो you can easily see how the quark is varying within these particles, and they are symmetric. They are very ordered way of variation of quark. You don't have to remember, you just remember the rule and you can make the particles. So let us first what I have written, I just read out कि जो आपका इस ग्राफ को बनाने से पहले जो हमारा पिक्चर है, एक्चुअली ग्राफ भी नहीं कहेंगे, that is picture. So the underlying symmetry of the quark structure within the mesons and baryons, the Gell-Mann, Nishijima, and there is one more scientist, Murray and George Zivik. They have plotted a graph and they got the Nobel Prize for that also, because वो equation भी लिखा, उन्होंने ये भी शो किया कि भाई quark exist करते हैं और quark होने चाहिए, you have to measure that. We are saying that that is there, and there is a symmetry between these quark, how they are arranged in these particles, and we can check from this particular graph. So they have just made the two-dimensional plot between T3 and between S and T3. T3 is along the horizontal axis. S is actually the strangeness quantum number, and T3 is the third component of isospin. And let us first make for the mesons. So mesons, we have two kind of mesons. There is one more message क्या है? Recording मैंने start कर दिया है. If you're okay, so message was previous one. So we have two different kind of mesons. One is a spin 0 and one is a spin 1. So integral, दोनों का integral spin है. They are something like a bosonic particle because they have two quark. और quark का individual spin half होता है, तो half can be added up or they can be subtracted. I mean, they can be anti-parallel or they can be parallel. So there are two possibility only. तो mesons के लिए दो ही possibility है, उससे ज़्यादा आपके formation नहीं हो सकते हैं because it's always a pair of quark and an anti-quark. So what they have done, let me choose the color also, so that let me choose green color for T3 axis. This is T3 axis, and we will use, let me use black color for strangeness. This is S. So mesons are having a quark and anti-quark pair. So you can, all the spin 0 mesons, you have to check how many mesons you have with a spin 0. And you have to plot on this particular curve. So let us start plotting and what are the different value we can get. So T3 की जो possibility है वो एक बार हम देख लेते हैं क्या क्या possibility है. That is either 0 or 1. That is only possible because spin half particle है, तो या तो parallel होंगे या anti parallel होंगे. Anti parallel में 0 आएगा, parallel में वो 1 आ सकता है. तो there is only possibility of 0 and 1. T3 also. T3 के लिए भी क्योंकि T3 spin और charge दोनों से related है, so you can only get half. You can add them or you can subtract them. So that is 0 or 1. Not exactly subtracting, it is anti parallel. So the known particle, which is your pi particle, just make it with different color. So I just mark it with 0. Sorry, blue color. So this is a first particle, which is actually 3 particle actually right here. So pi is one of the particle जो आपने पहले भी देखा हुआ है, pi meson, pi which is being exchanged between the nucleon. So pi 0 is here. And then we have 1, and here also we have 1, here also we have 1 unit, that is here. So this is 0, this is half, and this is 1. This you can say it is half, this is half, and this is -1, this is +1. This is similarly you can have +1 and this is -1. The strangeness की value 1 भी हो सकती है, +1 भी हो सकती है, 0 भी, this is 0, 0 भी हो सकती है, -1 भी हो सकती है. और T3 की value 0 हो सकती है, half हो सकती है, 1 हो सकती है, and so on. You can have 3/2 and so on. You can increase the value. But in mesons we don't have spin T3 value half. We only have the 0 and 1. So यहाँ पे हमारा particle आता है. Next one is pi plus. And similarly, symmetrically, we have pi minus. So pi 0 and pi minus and pi plus, they are non-strange particles. So they are plotted only on the horizontal axis with strangeness number 0. तो इन तीनों particle के लिए आपका strangeness number 0 है, and you have plotted them here. Okay, then we have another particle. There is a possibility that the spin arrangement in such a way that you can have, if the strangeness is different, if the strangeness is not exactly 0, if it is 1 or -1, then you can have a possibility of half spin also. So half spin की possibility है, और half spin आपका आता है here. It is with +1, and here is one particle which is actually K particle, K plus. And then you have another particle which is here, which is must be K0. And then you have another particle which is somewhere here, which is the strangeness negative, which is anti-particle of this one, which is K plus, and this is K minus. And for this anti-particle, which is K0, you will have another particle which is somewhere here. That is half T3, and strangeness is now -1. For this, strangeness is +1. So this is K0 and star. So that is something like an antiparticle for this one. And we also have another particle here, which is at 0, means their value is, means strangeness is 0, T3 is 0. So that is eta bar, and eta, actually eta bar नहीं लिखते हैं उसको, ऐसे लिखते हैं hyphen. So eta is this and eta is another. So 3 particles are there. So when you look at this one, it makes an something like a octade, or octate कहते हैं इसको, octane. When you join them, it is something like this. ये प्लस है, प्लस वाला मैं इसी लाइन के नीचे आ गया, तो प्लस है, ठीक है. So this is 1 2 3 4 5 6 1 2 3 4 5 6 7, and not exactly it, but it has side something which is 1 2 3 4 5 6 side. So this is something called as octade of meson family. And similarly we can make for spin 1 particle. So those is mesons which is having a spin 1. So we will draw that also. यहाँ पे हमने सारे spin 0 के लिए draw किया है, but we have drawn these 2 particle also which have spin half, because their strangeness is different. So this is something like a very symmetric kind of picture, and how the quark is within these particles. So if you go for the quark model, so this K, which is here, it has a quark composition of this one, U and S bar. U is the up quark, sorry, uni. So, when you have in this side, it is D. When you're of means you can say right hand side of this particular vertical line, it is always U. When you're on the left hand side, it is always D. So this will be U and S bar. So when you're moving from this side, यानी आप अगर positive axis की तरफ move कर रहे हो from left to right, then D will change to U. D will change to U. आप जब भी T3 के एक्सेस में आप पॉजिटिव वे में मूव कर रहे हो, मींस लोअर टू हायर वैल्यू, then D will change to U. Here also we have U bar, which is anti, and D is normal, and this pi is D bar and U is normal. So again, this D has changed to U, but U bar, which is anti, that has changed to D bar, which is anti. So this D has changed to U. ये मत imagine करना कि U bar has converted into U. So D has changed to U. And this U bar, which is anti, in this side, normal D is possible and anti-U bar is anti-U is possible of quark. Similarly, here you have normal U is possible and anti-D is possible. These are quark composition we are writing. And when you write for this pi 0, so that is D and D bar both when it is on same line. ठीक है, अब नीचे आ जाते हैं. नीचे हमारे पास स्ट्रेंजनेस -1 है, और लास्ट टाइम हमने लिखा था स्ट्रेंजनेस की वैल्यू क्या आती है, -NS बार. तो अगर हमारे पास स्ट्रेंज क्वार्क है तो माइनस साइन आएगा स्ट्रेंजनेस वैल्यू. इट मींस दिस मस्ट बी हैविंग अ स्ट्रेंज क्वार्क. Q bar S, which is normal, and this will be D bar and S, which is normal. ऊपर वाले में देखो S bar है, that is why we are getting plus as a strangeness value. Here S is normal, so that is why we are getting -1 as a strangeness. And इस साइड में जितने भी आपको मिलेंगे U, वो सारे बार के साथ होंगे. इस साइड में जितने भी आपको D मिलेंगे वो सारे बार के साथ होंगे. और इस साइड में सिर्फ आपको D नॉर्मल मिलेगा, और इस साइड में आपको D आपका U D आपको नहीं मिलेगा. ये D तो मिलेगा नहीं, U नॉर्मल आपको मिलेगा. So when you are moving in this way, D is converting into U. If it is a U bar, means anti-U, that will convert into a you can say a D anti. And you can also draw one more axis. This is a only two axes, but in the same dimension you can draw one more axis, and I will use a different color, and I will show you what that one is. So let us make it red. So with red you can see this line also, which is I'm drawing this line, and then another line, then another line. So this is Q की वैल्यू यहाँ पे क्या है +1, Q की वैल्यू क्या है 0, and Q की वैल्यू क्या है -1. So you can make another line also. Normally इस line को हम बनाते नहीं है, but this is something which is concerned with S and T bar. But book कई बार एग्जाम में आता है draw the charge T3 and S octade for a mesons with spin 0. So you have to make this particular diagram, and we explain the all the particle which is existing in this particular diagram and their charges भी बड़े symmetrically way में mentioned है. All these are +1 charges, all these are 0 charges, all these are minus charges, and in upper side you have a strangeness plus, and downward you have a strangeness minus, and -1 यूनिट, ऊपर एक प्लस यूनिट का है, और T3 की वैल्यू आपकी 0 and 1 है जो इस वाले एक्सेस पे, बाकी जो स्ट्रेंजर्स वाले एक्सेस पे आ गए उनकी स्पिन की वैल्यू आपकी हाफ. ठीक है, तो दिस curve is normally used to come in exam, and you have to make this all the three axes, and you have to mark the point. So this is for spin 0 only. Similarly you can make for spin 1 particle. So I will just make for spin 1
Sir,
particle. Then हाँ बोलो. Then we will go for the baryon.
K
हाँ
star
बताओ.
plus
कौन सा
K star
K
plus नहीं आएगा इसमें.
K स्टार प्लस वो इसमें नहीं है ना, वो स्पिन 1 में है, स्पिन 0 में नहीं है.
Yes sir.
वो स्पिन 1 वाले में. तो मैं एक बार वो भी ड्रॉ कर देता हूँ. ठीक है, so let us go with the green line. So green line is here, and then we have the black for the strange, and then we have this. You can हमने ब्लू से लिखा है ना सब कुछ, तो ब्लू से हम मार्क कर देते हैं उसमें. So in this case for blue, again you have to mark these numbers. This is 1, this is -1, this is 1, this is again 1 with plus sign, this is again -1, and your half also. Okay, so in this case we have rho particle here, which is rho is here, rho minus and rho plus, and we have rho 0 somewhere here, it is 0. Okay? So these are the particles. रो हमने कैलकुलेट किया था शायद वो those mesons which are carrying the repulsive force, repulsive nature of the strong forces. So rho और omega जो है they are carrying the repulsive kind of interaction. Then you have K plus star which you are talking about, that is here. ये थोड़ा सा छोटा बन गया, गैप मैंने थोड़ा सा छोटा ले लिया. This one gap should be here somewhere here. So this is your K plus star. This K plus star is different from this K plus because of spin value. ठीक है, तो दोनों K plus ही हैं. They have a similar kind of thing, but their spin is different. So their quark spin arrangement is different. यहाँ पे quark का spin arrangement इस sense में है कि they are giving you the total angular momentum or total spin value, spin angular momentum as 0. But in this case, they are parallel and they are giving rise to 1. So this is what the difference is. Okay, so that is why this particle is different. Otherwise composition में कोई ज़्यादा difference नहीं है. इसका भी जो composition है वो U और S bar ही है. Next one is here, which is we have K 0 and star, and similarly we have here also, and we have here also. So these are K minus and star, and this is K 0 and star. ठीक है, तो यहाँ पे K0 और K0 स्टार हमने लिखा ही था. अच्छा, K0 स्टार नहीं, यहाँ पे मुझे बार लिखना चाहिए था. जब यहाँ पे हम स्टार यूज कर रहे हैं तो आई विल राइट एज, मतलब कंफ्यूजन है. दिस इज एंटी पार्टिकल ऑफ दिस वन. तो इंस्टेड आई एम यूजिंग स्टार हियर बिकॉज आई हैव टू यूज फॉर स्पिन 1 पार्टिकल. तो यहाँ पे हमने K0 स्टार रखा है, तो K0 स्टार के ऊपर हम बार लगा देंगे. दैट इज एंटी फॉर दिस. ठीक है, बस ये ध्यान रखना, एंटी फॉर दिस वन. एंड वी हैव ओमेगा एंड 5 पार्टिकल ऑल्सो. तो 2 पार्टिकल और हैं यहाँ पे. omega or phi. So they all are related with the spin interaction and charge interaction, all kind of interaction within the न्यूक्लियस. सो ये जो पार्टिकल जितने भी आपके जो नॉन स्ट्रेंज है ना, यानी जिनका स्ट्रेंज नंबर 0 है, तो दे all are existing within the nucleus and they are being exchanged between the nucleons for the strong interaction. बहुत क्लोज है तो रिपल्सिव के लिए अलग मेसोन्स होंगे और अट्रैक्टिव के लिए अलग मेसोन्स होंगे, और जो वो मेसोन्स होंगे जिसमें कि स्पिन का भी अरेंजमेंट फॉलो हो रहा है कि अगर आपका किस तरीके का स्पिन है और किसके बीच में इंटरेक्शन हो रहा है, तो दैट विल हैव अ डिफरेंस. सो ऑल दीज आर विद इन द न्यूक्लियस, but they exist only in the reactions only. So again you make the octet and octet आपने draw किया and you get similar kind of picture. तो दोनों में बहुत डिफरेंस नहीं है, दोनों दिखने में बिल्कुल सेम है, और सिर्फ फर्क इतना है कि पार्टिकल्स का वो डिफरेंट हो गया है, बिकॉज दे ऑल आर स्पिन 1 पार्टिकल, दे ऑल आर स्पिन 0 पार्टिकल. नाउ again you can make the third axis, which is your charge axis, and that charge is this one. Charge is with red one, so that is this one. Again you can see this is q equal to +1, and this one is q equal to 0, and this one is q equal to -1. So they have seen this. पहले से पार्टिकल डिस्कवर्ड हो चुके थे, प्रिडिक्टेड थे कि उनका स्पिन वैल्यू ये है, और टैबुलेटेड फॉर्म में होते थे वो सारे के सारे, किस में होते थे? टैबुलेटेड फॉर्म में. जैसे हमने इलेक्ट्रॉन का टेबल बनाया ना, वैसे ही मेसोन्स का भी टेबल होता है जिसमें स्पिन की वैल्यू, चार्ज की वैल्यू और कोई प्रॉपर्टी है उसकी वैल्यू लिखी होती थी, मेंशन होती थी. मींस क्वांटम नंबर एस मेंशन होता था, सी होता था, बी होता था और टी होता था टॉपनेस या ट्रूथनेस के लिए. तो दैट इज ऑलरेडी मेंशन देयर, बट दे हैव understood in this way, and they have just took these two axes T3 and S and they have drawn the curve. After drawing this, they are easily able to predict the quark composition. तो हमेशा जब भी हमारा इस साइड वाला होगा पार्टिकल, यानी स्ट्रेंजनेस आपकी ये है, ये T3 है, तो स्ट्रेंजनेस के राइट हैंड साइड में जितने भी पार्टिकल उसमें नॉर्मल यू होगा हमेशा, और स्ट्रेंजनेस +1 है तो इट मींस देयर इज अ एंटी स्ट्रेंज quark is there. Similarly, this will have normal D and anti-strange quark. जैसे हमारे यहाँ पे, when you have lower side, when you look at, so that is U bar. For this one, it is U bar and normal S, and this one is U, sorry, D bar and normal S will be there. So you can even say in this way कि जब भी हमारा स्ट्रेंजनेस प्लस होगा तो हम नॉर्मल यू एंड डी यूज करेंगे, जब हमारा स्ट्रेंजनेस नेगेटिव होगा तो हमारा यू बार और डी बार यूज होगा. तो विल सी द अदर थिंग्स, कहीं और भी कोई एग्जिस्ट करता है. देयर आर पिरामिड आल्सो फॉर दीज different particles. We have pyramid also, but we will not go in a pyramid because हम सिर्फ 3 नंबर पे फोकस करेंगे, S, T3 and Q, 3 नंबर पे फोकस करेंगे. इफ यू इंक्लूड द charmness, truthness or bottomness, then you make further more dimension, that is 3-dimensional system आ जाता है. तो वो हम ये वाला हम यहाँ पे डिस्कस नहीं करेंगे, but when you discussing these you can make in a 2-dimensional sense. Now we come to the this arrangement, baryon arrangement. So we have done for the mesons, similarly we can do for the baryon. So baryon are 2 category, spin half baryons, and we have a spin 3/2. तो यहाँ पे 0 और 1 वाला स्पिन नहीं होता है, यहाँ पे हाफ और 3/2 वाला, बिकॉज दीज आर फर्मियंस, और ऊपर जो थे वो सारे बोसॉन्स थे. सो फर्मियंस आर which occupy space, which is not a force carrying particle. So mesons हमेशा force carrying particle है, which are being exchanged between nucleon, and these are actually the things which is exchanging them. So ऊपर वाले हम ऑक्टेट कहते हैं, और नीचे भी जो ड्रॉ करेंगे तो एक तो ऑक्टेट बनेगा, दूसरा कुछ और बनेगा. तो वी विल सी व्हाट दैट पिक्चर इज. अगेन वी हैव टू मेक द 2 एक्सेस इन द सेम सेंस. तो ये एग्जाम में 10 नंबर का क्वेश्चन पक्का आता है. सिर्फ यही पेज है ना, जितना मैं पेज अभी लिख रहा हूँ, सिर्फ ये पेज आपके ऊपर वाला पार्ट 10 नंबर का आ सकता है, नीचे वाला पार्ट 10 नंबर का आ सकता है. यू हैव टू ड्रॉ देम, यू हैव टू मार्क देम, एंड यू हैव टू मार्क द क्वार्क वैल्यू आल्सो. दैट्स ऑल. तो अगर ये टेबल याद कर लोगे अच्छे से तो कोई दिक्कत नहीं होगी. सो लेट अस मेक We don't have any strange +1 baryon. We only have a strangeness, means there are strange baryon exist, not एंटी स्ट्रेंज. तो जो +1 कौन से होंगे जिसमें एंटी स्ट्रेंज वेरियंस आते हैं, तो एंटी स्ट्रेंज वाला वेरियन वी डोंट हैव. सो वी हैव स्ट्रेंज वेरियंस ओनली. मेसन्स में हमारे पास पॉसिबिलिटी थी दैट एंटी स्ट्रेंज मेसन्स इज पॉसिबल, जिसका कि स्ट्रेंज नंबर आपका +1 था, बट इन दिस केस वी डोंट हैव दैट काइंड ऑफ पार्टिकल. सो वी विल मेक द एक्सेस, this is your T3 and this is your strange. Sorry, let me make it with black. So black is for strange. कुछ black सा है, कुछ दाल में काला है, इसलिए उसको हम strange को हम black से बना रहे हैं. Green is which is allowed things, and we mark the particle with blue. Blue is which we can mark the particle. So numbering, this is half and this is 1. This is half and this is 1. So this is obviously plus, this is minus and this is minus. यहाँ कहीं मैं भूल जाता हूँ कि प्लस माइनस का है, तो याद रखना कि वो प्लस माइनस है, ठीक है. एंड दिस इज 0 ऑब्वियसली. सो नॉन strange and spin half, what are those baryons are? कोई ऐसा बेरियन है हमारे पास जिसका कि स्पिन हाफ है और जो स्ट्रेंज भी नहीं है? आई थिंक वी हैव, which is non-strange. Yes, which is non-strange and spin half. And isospin is T is also half, but for proton it is plus half, and for neutron it is minus half. So they are the lightest member. So you have to mark somewhere here. So they on octet they come here. Then you have okay, I have to mark the strangeness also. This is 0 and this is -1 and this is -2. Then we have a particle which have strangeness -1, but spin is means total spin is minus T3 value is, because there are 3 particles actually. So next generation है उसमें 3 particles हैं. So their summation, which is somewhere here, means their strangeness is -1, there is strange particle, and with -1 as a T3 value, because there are 3 members. Last time हमने check किया था, अगर 3 member होंगे तो तीनों के पास आपकी T3 की value डिफरेंट होगी ना. आप एवरेज नंबर निकालते हुए, मैंने लास्ट टाइम मैंने T3 की कैलकुलेशन आपको दिखाई थी करके कि कैसे करने. जितने मेंबर हैं उतने नंबर तो हमें चाहिए ही चाहिए, या तो 2 मेंबर होंगे, या तो 3 होंगे, या 4 होंगे, या 5 होंगे, एंड सो ऑन. 5 तो शायद पॉसिबल है नहीं, हमारे पास अभी तक कोई ऐसा मिला नहीं है. सो वी हैव दीज पार्टिकल एज समेशन. दीज आर समेशन पार्टिकल. This is minus charge and this is 0 charge and this is plus charge. Okay. And we have another lambda particle which is having strangeness -1, but the spin T3 value is 0. So इसका कोई दूसरा भाई है नहीं, ये इकलौता है. तो अपने घर में ये इकलौता है. यहाँ पे 2 थे, तो दोनों को शेयर करना पड़ा T3 का वैल्यू. एक को प्लस हाफ मिला, एक को माइनस हाफ. टी की वैल्यू हाफ है, बट ये 3 पार्टिकल हैं तो तीनों को आपको शेयर करना पड़ेगा. तो तीनों का डिवीजन माइनस, मतलब हाफ से तो नहीं चल सकता ना. हाफ 0 हाफ तो पॉसिबल नहीं है. तो -1, then 1 unit is 0, then 1 unit is +1, and this is having no one. So सारी प्रॉपर्टी इसी के नाम जाएगी. जब भी इसके अगर कोई फादर होंगे तो सारी प्रॉपर्टी लैम्डा को मिलेगी. Then we have the next category which is again having only 2 set of particles. So there again we have only 2. So they are epsilon. इसका किसी ने नाम ढूंढा कि एप्सिलॉन कहते हैं, क्या कहते हैं? मेरे को सब ध्यान नहीं आ रहा है, मुझे ढूंढना पड़ेगा. इतना एक बार क्लास खत्म हो गई, याद ही नहीं रहता कि कल के क्लास के लिए क्या करना था. सो दिस इज समथिंग लाइक, मैं इसको वो कहता हूँ कैपिटल थीटा, बट दिस इज समथिंग एल्स. एप्सिलॉन या कैपिटल एप्सिलॉन यू कैन से. सो they are of minus and 0 charge. They are of minus and 0 charge. So if I look at the picture, what they make, it is similar to the octet which mesons have made. आप देखोगे तो ये सेम उसी, इनकी स्ट्रेंजनेस -2 है दोनों पार्टिकल. सो दे आर वेरी स्ट्रेंज पार्टिकल, stranger than these summation. So again, this is a octet, but this octet is made by spin half baryon only. Okay. Now we will write the quark composition. And if I write the quark composition, neutron proton का पहले लिखते हैं. Proton का क्या होता है? U and D. Obviously these are triplet state. We have 3 quark within these baryons. एक second hold करना. Okay, so this is octet. Sometimes it is called as set of 8 particles, but I don't think any such kind of definition should be there. It is family of 8. I don't know how this 8 is being counted. इसमें 8 है, देखना 1 2 3 4 5 6 7 8. Yes, according to this it is the mesons का जो octet है, that is not exactly a octet, but what about these particles? ये कौन से particles है? अच्छा, इसने alphabet ही लिख दिया. So what is this alphabet is called? Psi. So we can say psi. It is a capital psi. It's a capital theta. ये capital psi है ये. Okay. Capital psi. But psi name से शायद नहीं है particle का. Particle कुछ और कहते हैं. मैंने किसी को सुना है. It is something else is called this particle. If it is capital psi, तो it is psi. psi कहते हैं ना. ये ऐसा ही लिखा है ना इसमें आपका. Smaller तो आपको curly जैसा होता है. Capital में आपने ये लिखा है. So that is psi. तो मुझे लगा कि इसने particle भेज दिया. साई या साई जाई यू कैन से. अगर आपने एक डॉट लगा दिया तो जाई. बट आई विल सी व्हाट द नेम गिवन टू दीज पार्टिकल्स. सो यस, मुझे लगा कि ये पार्टिकल बता दिया अल्फा बीटा गामा सारे कहाँ पे हैं, वो तो मैं दिख ही नहीं रहे. आई थॉट व्हाट इज दैट, किस क्लासिफिकेशन में आ रहे हैं. So that is actually alphabet, Greek alphabet he has shared. Okay, so we come to the quark model and we have a set of 3 quark. ऊपर तो हमारे 2 थे. ऊपर हमारे family of 8 नहीं है because baryon give you the family of 8. So there are 8 members in this particular thing. There are 8 members total. 1 2 3 4 5 6 7 and 8. So for this we can say octet. But mesons have more than 8. तो वहाँ पे एक्चुअली जो सेंटर वाले ना, वहाँ 3 पार्टिकल आ रहे थे. तो आपके 1 2 3 4 5 6 7 8 9 पार्टिकल हो रहे हैं. तो दैट इज not exactly a octet, but it pictures look like something like that one. Okay, so we will make the charge axis also in this same graph. So let me just make you the charge axis with I think that is red one. ठीक है. तो again you can see quark पे फिर दोबारा आएंगे कि quark की composition क्या है. So this is your plus charge. Q is +1 and all these are with Q 0. Q is 0 and all these are with Q -1. So again you can make this axis also. तो T3S और Q का एक्सेस आप ड्रॉ कर सकते हो. बट T3 और आपका S तो परपेंडिकुलर होते हैं, बट दिस वन इज एट ऑब्लिक एंगल बिकॉज ऑफ योर डिजाइन एज यू सेलेक्ट द points according to your T3 and S value. Now we come to the quark composition of these and how they are changing. Again, it will change in the same way. If you are moving from right to left, then U will change. If you are moving from left to right, then U has to increase. तो एक तरफ U increase होगा, एक तरफ U decrease होगा. And when you go in a bottom way, then S has to increase. Okay, so this is UUD, and we know for neutron it is DDU. UDD actually. ठीक है. तो यहाँ पे क्या हुआ, एक सेंटर वाला U आपका चेंज होकर के D बन गया. तो when you are moving in this way, D has to increase. When you are moving in this way, U has to increase. So I can mark that also. When you're going in this way, U has to increase, and when you're going in this way, D has to increase. And when you're going in a bottom, then S has to increase. This is what you have to remember. So when you're going into bottom, होने तो 3 ही क्वार्क हैं, तो हमें U, D और इनमें से ही चेंज करना होगा. तो जो आपका जब इस डायरेक्शन में जाओगे तो ये क्या करोगे, आप U को रिमूव करोगे. बिकॉज इन दिस साइड if it is on normal, means if it is a normal particle, if it is not a strange particle, then U could be there, but as the strangeness is more, then D and U could be the more dominating in these means in the quark composition of any particle. तो summation पे जब आते हैं तो summation का है d d s. तो आपका जो एक u बचा हुआ था वो u भी आपका s से replace हो गया. In the same sense you can easily write for this also. It will be u and s. आपका जो d extra था वो इसमें convert हो गया. So this is strange. When you write at the center, center will have u d s all the three. क्योंकि ऊपर आपके पास यहाँ पे तो कुछ लिखा नहीं था, but u d and s is there. And when you look at this, u दो हैं, एक कम हो गया, यहाँ पे गायब ही हो गया. When you go in this direction, there are two d, only one is left, and there is no d. So you can see this, how you have to write u and d. When you go further, then this will have only one d and two s. Again, because s has to increase, strangeness has to increase. तो एक और d को आपको sacrifice करना पड़ेगा. यहाँ पे जब नीचे आओगे तो it will be uss. एक r भी होता तो हमारा ussr हो जाता. Which is not there actually. ना तो ussr रहा, ना तो u. Now it is a Russian Republic kind of thing. Republic of Russia. Okay, so that was a non-laughable joke. So this is, you can say it is a octet, which is family of 8. You can say family of 8. Eightfold symmetry भी कहते हैं कई बार, या 8 members. You can say eightfold symmetry or eightfold way. Okay, so now we come to the spin 3/2. So there are many particles. So now this will make a different kind of picture and we will have a different name. ये थोड़ा सा मैं ज़्यादा लिखते लिखते इधर चला गया, मुझे गैप देना चाहिए था, but whatever. So now we come to the spin 3/2. So let us try to make, and we will fit all those different particles which can be fitted somewhere in this case. So let us choose first the green one, which is for T3. And then we have black one. I will mark also. This is your 0. This is your half plus half and 3/2. And we also have 1 which is marked here. तो सही से मैंने डिफरेंस किया नहीं किया, हाफ मैंने बहुत दूर बना दिया, मुझे यहाँ पे 1 लिखना चाहिए था, फिर 3 पे. लेट मी जस्ट मेक इट अगेन. Otherwise the picture will not look in a better way. No. So this is your T3 axis. Here it is 0. So I will make it this as a half. So this is 1. And this must be 3/2. Plus a, plus a, plus a. Similarly, we have minus half. We have -1 and we have -3/2. So now it is okay. Then we have 0 is this one, and we need to choose the black, which is a strange dark matter. We don't know what is dark matter, but we can imagine कि वो black से बना होगा कुछ, हमें दिखता नहीं है ना वो. So this is strangeness. So this will be somewhere here. I have to mark 1 है ना, तो 1 unit मैंने ये लिया, तो इसको भी 1 unit मैं यहाँ पे ले रहा हूँ. This is 1. Then this will be 2 and this will be 3. So this is 1, obviously -1, -2 and -3. Okay. So the first normal means non-strange, and those baryon which have a spin 3/2. Yesterday we have calculated that, जिसमें T3 की वैल्यू 3/2 आई थी. क्या पार्टिकल था वो जिसको हमने कल कैलकुलेट किया था? कल की कैलकुलेशन में है वो, उनका हमने T3 निकाला था. There are 4 members in that family. किसी को याद नहीं है? -3/2 आया था, -1/2 आया था, फिर +1/2 आया था, फिर +3/2 आया था. 4 आए थे हमारे पास वैल्यू. So they are delta particle, delta plus plus, delta plus, delta zero, and delta minus. These are the 4 members which have t value as half, sorry, 3/2, but T3 is -3/2, -1/2, +1/2, and +3/2. And they all are normal baryons. They are not strange baryons. Okay. And then we can plot those particle which is already there. -half जिसका T3 value है और strangeness आपका -1 है. So you can plot that also. You don't have to write something different value. It is summation particle. So you have here also, and you have this. Sorry, not this one, this one, this one, this one. -1 है ना, यहाँ पे ड्रॉट. So this is summation plus part. ठीक है, तो यहाँ पे हम उसे ड्रॉ कर सकते हैं. And obviously lambda भी आप ड्रॉ कर सकते हैं if you want to make. So lambda is capital lambda is also there. Then you have half, and their strangeness is -2. Again, you have plotted here. So this is capital psi. So psi is already there. So you can plot that also. This is minus and this is 0. Then you go further down. You go further down, and when you go further down, you don't have any T3 value. That T3 value is 0, and you have just a particle at this particular axis. So exactly on the strangeness, जो आपका strangeness axis है ना, उसी axis पे आ जाता है. So that is not having any, means T3 value is 0. उसका T value भी 0 ही होगा. T3 0 है तो T value भी maximum होता है T3 का, so that is 0. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 members. So when there are 10 members, so they are called decupellate. So they are called as decupellate. Decuplates. So this is another kind of picture, which is a something like a triangular picture. So if you just join them, so there will be something like this. So this is a family of 10, and they can be plotted in this. Now we will write the quark. First we will draw the this charge axis also. So let me draw the charge axis. So red one. This is a new, which is Q is +2. है ना, इसके पास 2 charge है. Then you have Q, which is +1. Then you have Q, which is 0. And then you have Q, which is -1. So you have 4 different Q value. Okay, now we will write the quark composition. This one is having all U. Everything is only up quark. You have only 3 possibilities. So you can have all U as 1, because you're more away from this axis in this direction. What I have said, when you're moving in this way, you have to just replace one U by D. So for this, we can easily write as UUD. And when you go further, then it is, you have to replace one more, that is UDD. And when you go in this side, so that will be DDD. Triple D. All the down quark is there, all the up quark is there. And when you go downward, we have already written here, so that will be DDS. this is summation 0, summation 0. So that will be your UDS and this one will be UUS. तो एक D को एक U को आपने S से replace कर दिया. When you go further, this is already there. So DSS, again one D has been converted into S, again one U will be converted into your S. So that is USS. So when you go further more, then only one D is there. So you have to make more strange quark. So that will be triple S. So इसका मैंने वो नाम नहीं लिखा. This is omega. So this is omega with minus charge. So this is completely a strange baryon. Completely a strange baryon. So all the quarks are strange quarks in this particular baryon. The problem is this: why we plotted these things. Obviously, this is more understandable. If I make it small, you can look at that. So picture आपको देखते ही clear हो जाएगा. So there is some kind of symmetry is there. So that is more handy things. Instead of remembering everything, you can just look at the picture and the picture is more symmetric, you can say. It is more understandable. So there are family of 8, family of, not family of 8, 8 से ज़्यादा है, इसमें भी family of 8 से ज़्यादा ही है. This is family of 8 and this is family of 10. So normally exam में आता है, make a octet of baryons with a spin half L, or make an octet or make a decuplet of baryons with a spin 3/2. So you have to make this and write the quark composition also. So you have to write the, in bracket you have to write the quark composition also in this particular picture. ठीक है. अब यहाँ से हम start करते हैं कि what these quarks are and why we need to define them. Is there any use or do we have evidence? We have the evidence, but that is an indirect evidence. We have not captured any quark. That is not possible. But we have the evidence कि हमारे पास quark का कोई evidence है कि हम ऐसी बस हवा में बातें कर रहे हैं और करते करते हम यहाँ पहुंच गए. So experiment has been done, and once the experiment has been done, then people have identified कि yes, something is there. So we will discuss only about the neutron and proton. And the problem which will occur when you define a quark means, जब तक, for example, if you are about for this one, all the 3 quarks are different. एक color choose करने दो मुझे. So is it clear to you what you have to draw and what we are discussing? Is it clear to you? T3 और S axis का ही हम main हमारा जो picture है वो T3 और S axis के बीच में ही picture है सारा. Q तो हम बना देते हैं, but Q नहीं भी बनाओगे तो it will be okay. But T3 और S is important. T3 यानी isospin का third component and S is the strangeness quantum number, and you also make the Q which is for concerned with the charge. So is it okay till now?
Yes, sir.
Okay. So whenever you have this kind of arrangement, then it is okay. Then there is no problem for defining a new quantum number for quark, because they all are different quark. So it is okay. If you want to fit within a very small space, that is okay, because we all the 3 are different. But the problem means appear when you have this kind of arrangement. All the quark are d quark, down quark, all are S and all are U. So when you have these kind of particle, how it is possible within a small dimension that is hardly of a 0.8 Fermi dimension, you can place 3 different particles within this one? That is not possible. So that is why the new quantum number is defined for quark, that is called as flavor, because spin is there, charge is there, and you can also have the momentum, which is angular momentum, you can say. So all the other quantum number is there with the quark also, as you have for electron, as you have for proton, as you have for neutron. So quark can also have all those quantum numbers. It is okay. But how, if you are saying this is a one particle, then it is okay. Then you don't need to say anything. भाई एक पार्टिकल है, उसका मैंने n वैल्यू बता दिया, l वैल्यू n l m s या और भी कोई नंबर है वो हमने डिफाइन कर दिया. That is okay if it is a one particle, if it is treated as a one particle. But within that, if you say there are three particles, then we have to define a new quantum number, because they all have n, l, m, s concerned with this one is same. It is same. So for all the d quark, these numbers are same. So how can this be possible if their quantum number is not different? How can they fit in this particular small dimension? So what we have to do, we have to define a new, just hold on, just hold on. ओके सो इन स्टाफ को कुछ नहीं कर सकते, नॉन टीचिंग स्टाफ या तो रूम के अंदर बैठ के बात करेगा या तो कॉरिडोर में इतनी तेजी से बात कर रहे हैं। ओके सो हम कहाँ पे थे वो भी भूल गया मैं, क्वार्क पे थे, हाँ ये यस दिस क्वांटम नंबर. So we have to define a new quantum number for these quarks, and that is called as flavor. FOFLAVOR भी लिखा रहता है, कई बार VOUR भी लिखा रहता है. दैट इज अमेरिकन और यूएस का इंग्लिश, जो दोनों ये अमेरिकन और यूके के इंग्लिश में थोड़ा सा फर्क है. कई जगह यू यूज करते, कई जगह नहीं. दिस अ फ्लेवर. सो वी हैव टू डिफाइन अ न्यू नंबर to these quark. So that is called as something which is color charge. Charge is there, but we have a new kind of, which is not exactly charge. You should not understand as a charge, but this is a color charge. So this is a new kind of quantum number you have to define to have the wave function of these quark. क्योंकि आपको wave function बनाना ही है, और wave function भी ऐसा बनाना है जो antisymmetric होना चाहिए, because fermions have antisymmetric wave function. They cannot be a bosonic wave function, so they cannot lie upon on each other. If one is occupying, then other cannot occupy the same space. So this is what we have to prevail that particular thing. So we have to introduce a new quantum number, and we will see what those quantum numbers are and how we have to define them for different quark. So this is called as flavor, and flavor come in a color form. So that is why it is called as color charge. The color charge एक new quantum number which is concerned with the flavor. So now, sorry, not flavor exactly, but we will see what the color charge are actually. फ्लेवर तो हमारा इवन ये भी है, U is a different flavor, D is a different flavor, S is a different flavor, and top and bottom is a different flavor. So these are flavor of a quark, and we have a color charge, and color charge is actually concerned with the color. So we will remember those colors also, कि वो कौन कौन से कलर हम डिफाइन करते हैं. और हमारे जितने भी पार्टिकल हैं, जितने भी फॉर्म्यूल्स आपको नेचर में मिलते हैं, दे ऑल आर कलरलेस, बट क्वार्क आर नॉट कलरलेस, दे हैव सर्टेन कलर. सो वी हैव टू डिफाइन इन दैट वे कि जब आप कॉम्बिनेशन बनाओ तो आपका जो पार्टिकल है वो हमेशा कलरलेस होना चाहिए, इवन दो योर क्वार्क इज कलर्ड. ओके, सो we will see the picture of this how people came to know about the existence of quark. So when you have a proton, and if you bombard them with a electron having a very good amount of wave function. Wave function means wavelength. Actually, I'm talking about the de Broglie wavelength. So if the de Broglie wavelength is roughly of 1 Fermi, ठीक है, हमने क्या किया, एक इलेक्ट्रॉन का वेव जनरेट किया, मींस बीम ऑफ इलेक्ट्रॉन, एंड दे हैव सर्टेन काइनेटिक एनर्जी. So obviously if it is having a kinetic energy, then it will have h upon p means lambda. So आपका मैटर वेव होता है. So if I make it up to 1 Fermi, then I see this particular proton as a single particle. There is no substructure. I don't see any substructure because it is roughly a 1 Fermi, and this size is also around 1 Fermi, 0.8 Fermi है. But sometime it is means it is experimentally reported around 1 Fermi or 0.9 Fermi. So 0.8 से ज़्यादा भी reported है. So it means the size is not fixed for the proton. So when you bombard these electrons, you don't see anything. There is nothing within the proton. Proton is a single, you can say a point particle, or it is a, you can say elementary particle, you can say. So when you just decrease the de Broglie wavelength, So what you do, you have a proton and you bombard with a smaller wavelength. Now this lambda is a little bit smaller. So let us say that is less than a Fermi. So maybe 0.5 Fermi. So that kind of electron you can bombard on a proton. So when you bombard on a proton, you able to see that there are three different scattering centers are present. Three different, because these electron, what will they will do? They will just bombard, they just do the scattering, and you are sitting with the detector, और डिटेक्टर आपने लगा रखा है, डिटेक्टर से आप क्या मेजर कर रहे हो, डी सिग्मा बाय डी ओमेगा, which we have already done for the Rutherford scattering. So if you try to fit this curve, whatever the curve you get, means with angle, you just plot the curve and you just use the formula that there is only one plus charge. And when you use only one plus charge and you try to see the scattering, whatever the scattering has been done as per your angular variation, that is not going to fit. Means the plus one charge is not exactly a plus one charge. Means your theoretical analysis and your experimental result is not matching. So as it was predicted, means ki these quark must be somewhere within the proton. So people have fitted with that particular calculation also. Means there are two up quark. Up quark have charge 2/3 and down quark has -1/3. This is the charge composition of up and down. So there are three centers. Means this is a center, you can say this is one center and this is another center. So I will make it with blue. Let me make it with blue so that it is a negative. This is a negative charge. So -1/3 E and +2/3 E. If you have that kind of arrangement and you do the calculation, then your this formula and its variation with angle is exactly fitting. 2/3 E and 2/3. So they have done with this kind of thing. So they're able to see, yes, the proton is not made up of a single it is not a single elementary particle. It is made up of sub proton particle, you can say, or you can say they are made up of quark, and these quark have fractional charges. So that is 1/3. -1/3 is one. It is there within the proton, and 2/3 is there, and 2/3. And when they have plotted the charge density of a proton, अभी तक हम charge density of nucleus plot करते थे, है ना, हमने स्टार्टिंग के फर्स्ट यूनिट में हमने चार्ज डेंसिटी प्लॉट किया. इफ यू रिमेंबर द कर्व, दैट कर्व वाज फ्लैट एंड देन ड्रॉप, and we used to use that we use that particular curve to define the radius of the nucleus. तो हमने matter density और charge density दोनों को plot किया था. That was something which is like this one, flat and then there is drop. So there is a skin thickness. So it means there is a charge density for these proton also, and they are not fixed. जो मैंने यहाँ draw किया ना, ये fixed है. They are constantly moving. They can even overlap each other. So when they saw this one, so they have seen something like this. The charge density is like this one. So as you move away from the, means whatever the radius you can define for a proton, so most of the charge is at the center. It is roughly around I think it is 0.2 Fermi or 0.3 Fermi, roughly. Means exactly I don't remember, but it is 0.3 Fermi. So most of the charge is somewhere here, and it has a very diffused kind of you can say skin for the this particular proton. So this was amazing. This was amazing. Means if you, and now people are even thinking, okay, let us reduce the size of this lambda. Then what we will see. So what could be the prediction? If I further reduce, if electron velocity is further increased, giga or less, more than giga electron volt, then what I will see in this proton. This is a charge density of a proton. This is not charge density of a nucleus. This is a charge density of a proton. And if you plot for a u, even मैंने तो एक थोड़ा कॉमन सा बना दिया है, बट नॉर्मली u और d दोनों का बनाते हैं. तो ये u का आता है और d का इसके नीचे आता है. So that is why they are saying कि d is 1 and it is 2 times, so there are 2 up quark. So there is 2 up quark and 1 down quark. तो चार डेंसिटी दोनों के अलग अलग प्लॉट होते हैं, मींस नेगेटिव का आपने अलग प्लॉट किया है बिकॉज स्कैटरिंग आपको दोनों कैरेक्टरिस्टिक मिल रहे हैं, नेगेटिव से भी स्कैटरिंग हो रही है चार्ज से, और एक पॉजिटिव है तो आपका अट्रैक्टिव है, नेगेटिव है तो आपका रिपल्सिव है, तो दैट विल शो यू 2 डिफरेंट काइंड ऑफ डेंसिटी। तो मैंने बड़ा ही एक रफ वे में आपको बता दिया कि दिस समथिंग लाइक दिस वन, so this is due to the down quark and this is due to the up quark. So you can see the intensity is more, so domination is more and domination is double time. So you can say there are 2 up quark rather than your one concerned with your or compare with your one down quark. So what will happen if you reduce the lambda further more? क्या prediction हो सकता है? Can we have any prediction? या कुछ भी prediction नहीं होगा, सब कुछ normal ही है। हाँ? What we can see means as you go on looking at the smaller dimension, you will see further more structure. So what the scientists have predicted that instead of these 3 basic quarks, this blue is the this one minus, sorry, minus this one. So minus 1 by 3, 2 by 3 and 2 by 3. And if I reduce the lambda furthermore, means I'm using a high energy electrons, and when they are scattering means I will predict something else. And what the prediction scientists have done is you will further have more predictions of quark, and you will have the soup of quark. Actually, you don't have only the quarks, but you have a soup of quark, anti-quark and gluons, because obviously the gluon is always there, the gluons are always there. So these are gluons. Actually gluons को हम spring के form में बनाते हैं, तो gluon का symbol है ना, so gluons will be there, but you can have further more gluons, and these gluons are actually divided into quark and anti-quark pair. So what they have thought कि अगर हम bombard करते हैं smaller उससे, तो we will have soup of quark. In that quark there are 2 kind of quark. These 3 quark is called as valence quark, and all rest are called as sea of quark. So within the sea of quark, you have a 3 valence quark, which is actually being seen as a net effect of the composition of quark. But there is not one quark, there's infinite number of quark, and it can have a strange bottom, top, all kind of quark, all kind of quark. But always इन तीनों को छोड़ करके बाकी जितने भी होंगे आपके पास, वो हाउ मेनी यू हैव, दैट मस्ट बी इन द पेयर फॉर्म, मींस अगर क्वार्क है तो उसका एंटी क्वार्क होगा, बॉटम क्वार्क है तो उसका एंटी बॉटम क्वार्क होगा, स्ट्रेंज है तो उसका एक स्ट्रेंज होगा, और ग्लूऑन्स भी एग्जिस्ट करेंगे. दैट इज व्हाई 1% of mass is due to these valence quark and 99% of mass is due to this sea of quark, or you can say soup of quark. They consume the 99%, and they are virtual, they are being generated and being annihilated, generated, created, annihilated, so you don't get any effect of that. That is why we miss the mass of these quark. अगर ये exist कर जाते हैं for time being, कुछ time के लिए, so the new proton will become heavier. So this is what the prediction is, but the prediction कुछ graph predicted है और कुछ experiment भी शायद कुछ proof है अभी, what exactly people are doing working on this. And if I look at the picture of you can say neutron, how neutron will look like when you bombard with the electron. तो प्रोटॉन में तो बड़ा ही यूजुअल है कि हमारे पास पॉजिटिव चार्ज जैसा ही कुछ दिखता है. सो न्यूट्रॉन इज वेरी अनयूजुअल. Neutron is also having 3 quarks, means up, down and down. So it has plus 2 by 3 and minus 1 by 3 and minus 1 by 3. So the total is 0. So total is 0. Even though the total is 0, when you draw the picture, means when you draw the density, charge density of a neutron with a distance that is in Fermi, so you get this kind of picture. Positive at the center, negative at the skin boundary, and then it is roughly 0. So it is something like an atomic picture. Somewhere at the center, it is a positive charge, and negative quark are most of the time they are staying at the boundary. And we are discussing this means quark structure within the nucleon or neutron, you can say. हम न्यूक्लियस की बात नहीं कर रहे हैं. And the picture is similar kind of atom. Means neutron is nothing but like a atom. सेंटर में एक पॉजिटिव चार्ज है और उसके साइड में या बाउंड्री पे नेगेटिव चार्ज है. सो दिस इज समथिंग लाइक दैट. आप बाहर से देखते हो तो इट इज जीरो बिकॉज द टोटल चार्ज इज जीरो, बट इट इज समथिंग लाइक दिस वन. The proton have positive charge only maximum time. Negative is very feeble, but in this case negative is a good amount, so all the negative are staying at the outside and center is a positive charge. So do we have something like a shell structure for neutron also? We can have that, and you can predict that. अगर आप करना चाहते हो इस पे काम, तो you can do that, and you can predict. What you have to do, you have to limit your size. Means the potential which you have to consider, that is a fraction of Fermi. Fraction of Fermi सारा काम हो रहा है. You can imagine, you can make those potential पहले electrostat से use करके solve करो, फिर ये दूसरा कोई formula use करो. You can do that. So you can predict the certain excited state of neutron also. So they are very unusual. Means अब ये इतना छोटा है कि ऐसे तो हम देख नहीं सकते, but still we have these. And all the quark which you are saying, this up down and all these strange quark, they also have the anti quark also. I mean, anti up, anti d, anti s. So there are so many possibilities. होते सिर्फ ये 6 quark हैं और उनके anti 6 quark हो गए तो 12 हमें पास. We have 12 quarks only. We don't have more than that. And we have 12 leptons only. So total is 24 particles are there which make up the universe. Visible universe, not other part, visible universe, 4% of the universe. So there are 24 particles only, जिसमें से भी सिर्फ 3 ऐसे पार्टिकल हैं जो स्टेबल हैं, बाकी सारे अनस्टेबल हैं. All of them are unstable. So I have asked you कि how many particles we have. We only have 24 particles. 6 leptons, 6 anti-lepton, 6 quark, and 6 anti-quark. So they make up whole of the universe, which you are actually measuring. 24. Handful 24 है. 24 में से भी 12 are particle, 12 are anti-particle. And rest other which we have discussed, those are bosons or W boson, Z boson or graviton or gluon. They are actually field particles. They are normally called as virtual particles. They just carry the field. They don't, they just do the interaction. That's all. They don't make up the heaviness in your system. They don't make the heaviness, or you can say they don't make the mass, or they don't occupy the volume. Actually, you can say in that way. So अभी भी क्वार्क में रह गया है, अभी भी हमारा कंप्लीट नहीं हुआ है. तो अभी हमें क्या करना है, मैं एक बार देख लेता हूँ कि हमें कितना टॉपिक रह गया. इससे क्वार्क का एक टेबल मैं आपको दे दूंगा, और उस टेबल में क्वार्क की सारी प्रॉपर्टीज, कि उसका स्पिन चार्ज या क्या है क्या नहीं है, दैट आई विल राइट. देन वी विल डिस्कस हमारा जो टॉपिक रह गया, कलर क्वार्क, दैट इज कलर चार्ज ऑफ अ क्वार्क, एंड ग्लूऑन्स. थोड़ा सा ग्लूऑन्स के बारे में डिस्कस करेंगे. हाउ मेनी ग्लूऑन्स आर देयर? देयर आर ओनली 8 ग्लूऑन्स, एंड हाउ द कलर चार्ज आर डिफाइंड फॉर दीज क्वार्क. तो हम कलर कैसे डिफाइन करते हैं और कितने कलर के हमारे पास क्वार्क होते हैं. यानी अप क्वार्क है तो हाउ मेनी कलर्स वी कैन हैव फॉर अप क्वार्क, हाउ मेनी कलर्स वी कैन हैव फॉर डाउन क्वार्क, हाउ मेनी कलर्स वी कैन हैव फॉर स्ट्रेंज क्वार्क, एंड देन वी हैव एंटी कलर आल्सो. सो यू विल गेट कंफ्यूज्ड एंड देन लेटर. ये इतने सारे, बट नाम इतने इजी हैं कि यू कैन रिमेंबर देम. तो नेम्स आर वेरी इजी, दैट इज व्हाई दे हैव केप्ट नेम्स सो इजी, सो दैट यू कैन रिमेंबर इजीली. जिन बच्चों का अब रह गया वाइवा, so we can start with the viva. I just end the recording. ठीक है, तो आज के लिए अब जिस बच्चे का है, please tell your roll number so that I can make you the presenter and you can present it. नहीं है तो फिर भी बताओ, है तो फिर भी बताओ.